Hello, students. I think I managed to get lesson 5.4 into one video. So let's get started. I'll go ahead and share my screen with you. Now, lesson 5.4 is on the point slope form. Okay. What is the point slope form? It's a different form of the equation, but first let's review the equations that we had learned, and let me just go over the page numbers. We're on page 338 and 341, which is parts 1 and 2 of lesson 5.4. Now, here's the equations that I had you learn. The slope formula, direct variation, parent function in regular and function form, and the slope-intercept form. The new one that I'm having you learn is the point-slope form. Okay. Now, let's review these. You may want to say them from memory with me. Anyways, slope formula is y2 minus y1 over x2 minus x1. Direct variation is y is equal to kx. The parent function in regular form is y is equal to x. In function form is f of x is equal to x. Slope-intercept form is y is equal to mx plus b. And now the new one, point-slope form. Point-slope form is y minus y1 is equal to m times the result of x minus x1, okay? Now you might be like, well, why are you teaching us so many different ways to do the same thing? Well, it's kind of like the best writers use like the same meaning, but pick like 5 different words that mean the same thing, because if you say the same word over and over again, it gets boring, okay? So math kind of has a lot of different ways to attack the same problem. The more that you know, the better that you get at math. So let me say what this form is and why we're going to be using it. In point-slope form, you can graph using only points and the slope. So the first form that we did a lot of work with was the slope-intercept form. Now in the slope-intercept form, kind of like the main idea is the slope. Like, hey, here's the slope, here's m. It's like super easy. In the point-slope form, the focus is a little bit on slope, but it's more on the points themselves. So given that you have a point, like in this case, I have the point -3, +6, okay? So if you know what the point is, and you know what the slope is, then you can substitute them into the formula. So let me rewrite the formula. Y minus y1 is equal to m times x minus x1. Okay, now this is our x value, and this is our y value. Now, in any given point, obviously to make a line you need several points. In any given point, the way that you look at it is one point has 2 parts, an x part and a y part. Okay? Now, in this given one, the x part is -3. Now, when I say y sub 1 and x sub 1, the sub 1 means we're talking about the exact same point. Okay? So that's all that means. If it was a y sub 2 and x sub 2, then it would mean a different point. So what I have to do here then is substitute the values in the point into the equation. So instead of x sub 1, I'm going to put -3. And instead of y sub 1, I'm going to put +6. Now you'll note that I just rewrote the rest of the equation around it. Now, just for consistency's sake, I'm going to keep writing everything else in black. Okay? I don't know if that helps, but I like color coding, as you already know. So now what I'm going to do is I'm going to try to simplify. So x minus -3, the minus cancels the negative sign, so you can rewrite that as x plus 3. Now, in problem 1, my goal here is to just simply write the equation with a point and with the slope. So the other thing that I have left is the slope. Where's the slope go? Yisai, you're correct. The slope is m. So just substitute -5 for the slope, and then just fill out everything else that we did. So the goal for problem 1 was to write the problem. Here, I'll just go ahead and fill that in, just so it's clear. To write the problem using just a point and the slope. So the steps are this, very simple. Using the given point, substitute in the values of the point for y1 and x1. Keep in mind that the order is different. In a point, x is written first, but in the formula, x is written second. So don't get those mixed up and end up sticking your y value here and your x value there. Okay? Make sure that you put them in the right places. And the given slope just goes in. So really, all you're doing with this lesson, or at least this part of the lesson, is just substituting. Now, I have a point slope form problem right here. Y minus 1 is equal to 2/3 times x minus 2. Okay, so it's y minus y1 is equal to m times x minus x1. Okay, so in this case, if I want to make a graph of it, let's go ahead and make a coordinate plane here. And I'll just move this down so it's obvious and clear for you to see. Okay, so to make a graph of it, simply put, I just need to come up with a point. Okay, now I want to remind you, this is my x value, this is my y value. So let me go ahead and just make a coordinate pair here, and I'll leave an empty one here just to show that I can put my points in. So basically, problem 2 is just the opposite of problem 1. I'm going to extrapolate out of the problem. Oops, picked the wrong color. Sorry about that. My x value, which is 2, and my y value, which is 1. Now, a little note. If you have the formula written and this is positive or this is positive or they're both positive, then that indicates that the numbers are negative. Because if that was -1 minus, or sorry, if I subtract -1, then I end up with +1. If I subtract -2, I end up with +2. So I'm just going to write this out. So if I have this is not the equation that we're using, but I'm just showing you because this is a really important thing. See how these are both written as positives. If I were to extrapolate the points out of it, then I would have -2, -1. Okay? Because when I put this and this into the formula, they combine with the minus signs to create positive numbers. But when I'm taking them out of the formula, then they go back to their form of being negative. Since these ones were already being subtracted, then I know that they are positive numbers being subtracted. Okay, so when I pull them out, I pull them out just as they are, positive numbers, however they were subtracted. Okay, so anyways, so I've got the 0.21. So starting from 0, I go up 2, and I go over 1. And there is my first point. Wait a second. I think I did that wrong. I was thinking slope. This is not slope. Okay. Mr. Bauer got something wrong. Ah, hate it. But that's okay. It's the point to 1. So I go 2 over and 1 up. That's the point. So since I got something wrong, this is a good lesson to show how easy, like I'm the teacher, I'm sitting here on YouTube messing this up. So I'm going to go ahead and fix this. Okay, just to show how easy it is, I was thinking of the point, but in reality, I jumped to doing slope, okay? So the point is my x value is 2 and my y value is 1. So 2 over and 1 up, and then that gives me the point. So it is interesting. I guess how you can see how you can confuse them, because the way that you find the spot of a point on the graph is very similar to how we do slope. So now that I know what the slope is, 2 over 3, then I can use the slope to find my next point. So in that case, I go 2 up and 3 over. 2 up and 3 over. Okay, now that I've got a line, I can connect my dots. Okay. Now, if you look in your book on page 341, there's another problem that says using 2 points to write an equation. Okay, and I'm going to go ahead and flip to the next paper here just so that I can have a clean sheet to write on for that. Okay, so let's say I have 2 given points. Okay, and those given points are on a graph. Okay, but I know what these points are because I can look at them on the graph. I was going to draw the graph, but I'm just going to save time because I know these videos can get a little bit long. So how can I write an equation for this with 2 points, but I don't specifically have the slope? Well, I can find the slope using the slope formula, which, if you remember, yes, Aaliyah, you remember it, y2 minus y1 over x2 minus x1. Okay, so there's my slope formula. So let's go ahead and fill them out. Here's my y values. Here's my x values. Now I color code these because I have found that students sometimes get them mixed up. Because here we're going from a top and bottom model to a left and right model. Okay, now if you color code them, then it's kind of easier to see the direction that you're supposed to be going. Okay, now which one is y1 and x1, and which one is y2 and x2? To be perfectly honest, that's up to you. You need to just make a decision. I'm going to make the decision that this one is number 1 and that this one is number 2. Okay? All right, so I could say this one's number 2 and this one's number 1. Basically, the thing that you want to avoid doing is getting them crisscrossed, where you use this being sub 1 of one and this being sub 1 of the other, something like that. So just make sure that wherever it says sub 1, you make sure you use these numbers. So I'm going to go ahead and rewrite my equation here. My y sub 1 is 4. my x sub 1 is 1. Now, let's go to 2. My y sub 2 is negative 3, and my x sub 2 is negative 2. Okay? Now again, I'm going to color code, which again, you don't have to color code, but this is just another layer of preventing you from messing it up. Okay, so let's take a look. The numbers in green are 1 and 2. I have 1 and 2. The numbers in blue are negative 3 and 4. I have negative 3 and 4. Good, I didn't screw them up and put them in the wrong places. Let's double check. My sub numbers are 1 and 4. So sub 1, 4, and 1. My sub 2 numbers are negative 3, negative 2. Sub 2 is negative 3. Sub 2 is negative 2. Very good. Now, I know I'm going kind of long on this. The idea is learn it well so that you can go short once you do it. Okay? So negative 3 minus 4 is negative 7. Negative 2 minus 1 is negative 3. So I have a slope of negative 7 over negative 3. But you can think of every fraction as a division problem. So a negative divided by a negative is a positive. So in essence, the negative here that's dividing is going to cancel the negative here that is being divided. So I end up with positive 7/3. Or basically 2 negatives make a positive. The signs are the same, the answer is positive. Just remember that. Okay, so now I know what my slope is. So y minus y1 is equal to m times x minus x1. Now that I know what the slope is, all I've got to do is substitute in everything that's missing. 7/3, I can substitute in for the slope. Now, all I have to do is fill in y1 and x1. Okay, so y1, if we remember, was 4. x1, we remember, is 1. So now I have written the equation. Y minus 4 is equal to 7/3 times the result of x minus 1. Okay, hope that helps. Thank you much.